This video is designed to teach you Arduino in just 10 minutes, giving you a simple introduction to its components, programming basics, and how to get started quickly. Arduino is widely used in Internet of Things because it can connect sensors, devices, and the internet to collect and share data. It is used in robotics because it can control motors, sensors, and movements of a robot. Commonly used in weather monitoring systems to collect and display environmental data using sensors. Arduino is widely used in education because it helps students learn electronics, coding, and real-world problem solving through hands-on projects. Used in security systems to build smart and low-cost protection devices using sensors. Finally, it is widely used in automation to control devices automatically without human effort, using sensors and programming. On an Arduino board, the TX and RX LEDs are small indicator lights that show communication activity. Digital pins are used to send or receive simple on-off signals. The reset button is a small push button used to restart the program. The USB connector is the port used to connect the board to a computer. The USB interface chip is a small chip that helps the board communicate with a computer through USB. The crystal oscillator is a small component that helps control time and speed of the system. The voltage regulator is a component that controls and stabilizes the power supply. The power port, also called the power jack, is where you connect an external power supply. The reset pin button is used to restart the program running on the microcontroller. 3.3V and 5V are power output pins that supply fixed voltages to components. GND stands for ground, acts as the 0V reference point in a circuit. VIN stands for voltage in that receives external power input, usually 7-12V. Analog input pins are used to read variable signals from sensors. A microcontroller is the main brain of an electronic system used in Arduino boards. ICSP stands for in-circuit serial programming, used to directly program the microcontroller. The power LED is a small indicator light that shows if the board is receiving power. Arduino is mainly programmed using the C and C++ programming languages, which are ideal for controlling hardware and working with electronic components. These languages are used because they are fast, efficient, and allow direct control of the microcontroller's pins, memory, and timing functions. When you write code in the Arduino IDE, it is actually based on simplified C++ syntax that is easy for beginners to understand and use in projects. The essential hardware needed for a Raspberry Pi project and how each component is important for building electronics and smart systems. First, the most important part is the Raspberry Pi board itself. The Raspberry Pi is a small computer that acts as the brain of the project. It can run programs, connect to the internet, and control different electronic components like sensors and motors. Without it, the system cannot function. Next, we have the USB cable. The USB cable is used to power the Raspberry Pi and also to connect it to other devices like a computer. It helps in transferring power and sometimes data, depending on the setup. It is essential for starting and running the Raspberry Pi safely. Another important item is the breadboard. A breadboard is used to build and test electronic circuits without soldering. It allows us to easily connect and remove components, making it very useful for beginners and for experimenting with different circuit designs. Then we have jumper wires, also known as super wires. These wires are used to connect different components on the breadboard and Raspberry Pi. They help transfer signals and power between devices, making the whole circuit work together. We also use resistors. Resistors control the flow of electricity in a circuit. They protect sensitive components like LEDs and sensors from getting damaged by too much current. Different resistors are used depending on the requirement of the circuit. Finally, we have sensors. Sensors are very important because they allow the Raspberry Pi to interact with the real world. For example, temperature sensors measure heat, motion sensors detect movement, and light sensors detect brightness. These sensors help in building smart systems like weather stations, security alarms, and automation projects. The optional hardware used with the Raspberry Pi, which helps make projects more advanced, powerful, and interactive. These components are not always required, but they are very useful for building smart systems. First, we have LEDs, light emitting diodes. LEDs are small lights used to show status or output signals. They can be turned on or off by the Raspberry Pi to indicate different conditions, such as whether a system is working, a sensor is active, or a process is complete. LEDs are simple but very important for visual feedback in projects. Next is the relay module. A relay module is used to control high voltage devices like bulbs, fans, or home appliances using the low voltage signals from the Raspberry Pi. It acts like a switch that allows the Raspberry Pi to safely control powerful electrical devices, making it very useful in home automation systems. We also have the LCD display. An LCD display is used to show text, numbers, and sensor readings. Instead of just seeing data on a computer screen, the LCD allows real-time information to be displayed directly on the project. For example, it can show temperature, time, or system status in a weather station or smart device. Another important module is the Wi-Fi module. This module allows the Raspberry Pi to connect to the internet and communicate with other devices. With Wi-Fi, the Raspberry Pi can send and receive data online, making it possible to build IoT systems like remote monitoring, smart homes, and cloud-based projects. We also use a motor driver. A motor driver is required when controlling motors because the Raspberry Pi cannot directly provide enough power. It helps control the speed and direction of motors, making it essential for robotics projects like robot cars and automated machines. Finally, there is the SD card module. The SD card is very important because it stores the operating system, programs, and data for the Raspberry Pi. Without it, the Raspberry Pi cannot boot or save information. It acts like the main memory storage of the system. Setup process. First, install the Arduino IDE, integrated development environment, on your computer. This software is used to write and upload code to the Arduino board. Next, connect the Arduino board to your computer using a USB cable. This provides both power and communication between the computer and the board. After that, open the Arduino IDE. In the software, go to the Tools menu and select the correct board type, such as Arduino Uno. Then select the correct port so the computer can detect the board. Now you can write or open a sample code, sketch, in the IDE. You can start with simple programs like Blink or Serial Print. Finally, click the Upload button to send the code to the Arduino board. Once uploaded, the program will automatically run on the device. The first program for Arduino sets pin 13 as an output using pin mode 13, output. This tells the Arduino that pin 13 will be used to send signals. In the loop function, the command digital write 13, high, turns the LED on. Then the program waits for 1000 milliseconds using delay 1000, which is equal to 1 second. After that, digital write 13, LOW, turns the LED off. Again, the program waits for 1000 milliseconds. This process repeats continuously, making the LED blink on and off every second. The program starts with a setup function, which runs only once when the Arduino starts. Inside setup, serial begin 9600 is used to start serial communication at a speed of 9,600 billion Australian dollars. Then serial print hello Arduino prints the message hello Arduino on the serial monitor. The loop function is empty, so nothing repeats continuously. The message is printed only once when the program starts. This video covers the basics of Arduino, including what it is, how it works, and why it is used in electronics projects. It explains the main components of an Arduino board, such as digital pins, analog pins, and the microcontroller, and how they work together to control different devices. The video also introduces simple programming concepts using C++ in the Arduino IDE, showing how code is written, uploaded, and executed on the board. In addition, it demonstrates basic projects like blinking an LED and printing messages to the serial monitor. By the end of this quick overview, you will understand how to set up Arduino and start building simple beginner level electronics projects.